Hey everyone, welcome to part 6 of our Microsoft Certified Azure Developer Associate Ultimate course. We are starting with question number 63 in this part of our series. You deploy an ASP.NET web app to Azure App Service. You must monitor the web app by using Application Insights. You need to configure Application Insights to meet the requirements. Which feature should you use? Now friends, the first requirement is automatically warn you of potential performance problems and failure anomalies in the web app. Your options are Smart Detection, Snapshot Debugger, Profiler, Multi-Step Test. And folks, you should make use of Smart Detection here. Smart Detection automatically analyzes telemetry and sends proactive alerts about performance degradations, failure anomalies, and potential issues. Now, the next part of the question is talking about automatically collect the state of the source code and variables when an exception is thrown in the web app. Again, you have the same four options. And friends, in this case, you will have to use a snapshot debugger. Snapshot debugger captures a snapshot of the process at the moment an exception is thrown, including local variables and the call stack. Now friends, the third part of the question is talking about capture performance traces of the web app without negatively affecting users of the web app. Profiler would be the right feature to use in this case. Application Insights Profiler collects detailed performance traces with very low overhead, so it doesn't impact end user experience. Let's look at question number 64 of the series. You develop new functionality in a web application for a company that provides access to seismic data from around the world. The seismic data is stored in Redis streams within an Azure cache for Redis instance. The new functionality includes a real-time display of seismic events as they occur. You need to implement the Azure cache for Redis command to receive seismic data. How should you complete the command? Now friends, there are basically three blocks that you need to fill in the whole command. And the correct command is now on your screen. Xread reads new entries and can block and wait for new messages, making it perfect for real-time consumption. To continuously wait for new data, use block, and 0 means wait indefinitely until new data arrives. And stream ID would be $, which means start from new messages only, not old history. Next question. You develop and deploy an Azure App Service web app that connects to Azure Cache for Redis as a content cache. All resources have been deployed to the East US 2 region. The security team requires the following audit information from the Azure Cache for Redis: the number of Redis client connections from an associated IP address, Redis operations completed on the content cache, the location in which the Azure cache for Redis instance was accessed. The audit information must be captured and analyzed by a security team application deployed to the central US region. You need to log information on all client connections to the cache. Which configuration values should you use? The first part of the question is talking about to store the log information. Your options are Log Analytics Workspace, Blob Storage Account, Data Lake Storage Zen2 Storage Account, Event Hub. Folks, you should use Log Analytics Workspace to store logs. It is best for collecting telemetry and running queries with Azure Monitor and can be consumed by downstream apps. Now, Blob Storage Account is best used for archival. Data Lake Storage Zen2 is typically used for big data analytics pipelines, and Event Hub is best for streaming to SIEM or external app. Now, the next part of the question is talking about enable client connection logging. And your options are diagnostic setting, managed identity, app registration, environment variable. Correct way to enable logging and send logs to Log Analytics is to use diagnostic setting. Managed identity or app registration is used for authentication, and environment variable is not relevant to Redis logs at all. Question number 66 of the series. You are developing an ASP.NET Core Web API web service. The web service uses Azure Application Insights for all telemetry and dependency tracking. The web service reads and writes data to a database other than Microsoft SQL Server. You need to ensure that dependency tracking works for calls to the third-party database. Which two dependency telemetry properties should you use? Your options are telemetry context cloud role instance, telemetry ID, telemetry name, telemetry context operation ID, telemetry context session ID. And friends, the correct answers are now on your screen. Telemetry ID is a unique identifier for the telemetry item itself. This is used to correlate a dependency call with its parent request. Now, telemetry context operation ID links all telemetry, which includes request, dependency, trace, exception that belong to the same end-to-end operation. Now friends, there is a link on your screen. Go through the link to understand these dependency telemetry properties in more detail. Question number 67. You develop and deploy an Azure App Service web app. The app is deployed to multiple regions and uses Azure Traffic Manager. Application Insights is enabled for the app. You need to analyze app uptime for each month. Which two solutions will achieve the goal? Your options are Azure Monitor Logs, Application Insights Alerts, Azure Monitor Metrics, Application Insights Availability Tests. Now friends, Application Insights send availability telemetry data to log analytics. With Kutso queries, you can aggregate results over monthly windows to calculate uptime percentage, making it perfect for long-term analysis. Now, Azure Monitor Metrics can capture availability percentage and can be aggregated over time ranges. You can view monthly uptime trends in Metrics Explorer or export them. Now friends, Application Insights Alert notify you in real time when conditions are met, but they do not provide monthly uptime analysis. Application Insights Availability Tests generate the availability telemetry in the first place, but that does not directly relate to analyzing monthly uptime, which is why I have ruled it out. Folks, if you are liking the content, do not forget to hit the like button and subscribe the channel. Let's look at question number 68 of the series. You are implementing an Azure solution that uses Azure Cosmos DB and the latest Azure Cosmos DB SDK. You add a change feed processor to a new container instance. You attempt to read a batch of 100 documents. The process fails when reading one of the documents. The solution must monitor the progress of the change feed processor instance on the new container as the change feed is read. You must prevent the change feed processor from retrying the entire batch when one document cannot be read. You need to implement the change feed processor to read the documents. Which features should you use? Now friends, the features that are given in the options are change feed estimator, dead letter queue, deployment unit, and lease container. Now the first requirement is monitor the progress of the change feed processor. Now friends, the change feed estimator provides insight into how many items remain to be processed and helps monitor the processor's progress. Now the next part of the question is talking about prevent the change feed processor from retrying the entire batch when one document cannot be read. The dead letter queue allows problematic documents to be moved to a separate container when they fail processing, preventing the entire batch from being retried. Now folks, the remaining options, deployment unit refers to how you package and deploy the change feed processor application. And the lease container is required by the change feed processor to track state and distribute work among multiple processor instances. Next question. You develop a solution that uses Azure virtual machines. The virtual machines contain code that must access resources in an Azure resource group. You grant the VM access to the resource group in Resource Manager. You need to obtain an access token that uses the VM's system assigned managed identity. Which two actions should you perform? Your options are: from the code on the VM, call Azure Resource Manager using an access token. Use PowerShell on a remote machine to make a request to the local managed identity for Azure Resources endpoint. Use PowerShell on the VM to make a request to the local managed identity for Azure Resources endpoint. From the code on the VM, call Azure Resource Manager using a SaaS token. From the code on the VM, generate a user delegation SaaS token. Now friends, the correct answers are now on your screen. There is a link on your screen, folks, which you can refer to understand the whole process in more detail. Option B is incorrect as the managed identity endpoint is only accessible inside the VM. And option D and option E talk about SaaS tokens, which are for storage, not Azure Resource Manager. So friends, you could either understand how I came to the solution by understanding the logic behind the question, or you could try the elimination approach. As you can see, the last two options can clearly be ruled out because you use SaaS tokens with a storage account. And then option B can also be ruled out because the managed identity endpoint is only accessible inside the VM. This leaves us with only two options, option A and option C, which are the correct answers. Let's look at question number 70. You are building a loyalty program for a major snack producer. When customers buy a snack at any of 100 participating retailers, the event is recorded in Azure Event Hub. Each retailer is given a unique identifier that is used as the primary identifier for the loyalty program. The retailers must be able to be added or removed at any time. Retailers must only be able to record sales for themselves. You need to ensure that retailers can record sales. What should you do? Your options are: use publisher policies for retailers, create a partition for each retailer, define a namespace for each retailer. Now folks, Event Hubs supports publisher policy. Each retailer can send events to Event Hub using a URI with its publisher ID. This enforces that the publisher, which is retailer in this case, can only publish under its ID. You don't need to create separate hubs partitions for each retailer, and retailers can be added or removed dynamically by managing SaaS tokens or keys. Friends, as always, there is a link on your screen. Go through the link to understand more about publisher policies in Event Hubs. Question number 71. You are developing an Azure service application that processes queue data when it receives a message from a mobile application. Messages may not be sent to the service consistently. You have the following requirements. Queue size must not grow larger than 80 gigabytes. Use first in, first out ordering of messages. Minimize Azure costs. You need to implement the messaging solution. Friends, the solution you choose is: use the .NET API to add a message to the Azure Service Bus queue from the mobile application. Create an Azure function app that uses an Azure Service Bus queue trigger. Does this meet the goal? You need to tell whether this is right or wrong. And friends, this is a correct solution. Let's understand some of the scenarios where Microsoft recommends the use of Service Bus queues. So folks, as per Microsoft documentation, as a solution architect or developer, you should consider using service bus queues when your solution needs to receive messages without having to poll the queue. With service bus, you can achieve it by using a long polling receive operation using the TCP based protocols that service bus supports. Your solution requires the queue to provide a guaranteed first in, first out ordered delivery. This is one of the requirements that we had in our question. Your solution needs to support automatic duplicate detection. You want your application to process messages as parallel long-running streams. In this model, each node in the consuming application competes for streams as opposed to messages. When a stream is given to a consuming node, the node can examine the state of the application stream state using transactions. Your solution requires transactional behavior and atomicity when sending or receiving multiple messages from a queue. Your application handles messages that can exceed 64 KB but won't likely approach the 256 KB or 1 MB limit depending on the chosen service tier. So friends, even though this was not one of our requirement in the question, but you should always take into consideration the message size when choosing service bus queues. Now, you deal with a requirement to provide a role-based access model to the queues. Your queue size won't grow larger than 80 GB. Again, this is one of our requirements. If the queue size is going beyond 80 GB, then you are not going to use service bus. You want to use AMQP 1.0 standards based messaging protocol. You envision an eventual migration from queue-based point-to-point communication to a publish-subscribe messaging pattern, which is pub/sub pattern. This pattern enables integration of additional receivers, which is subscribers. Each receiver receives independent copies of either some or all the messages sent to the queue. Your messaging solution needs to support the at most once and at least once delivery guarantees without the need for you to build the additional infrastructure components. Your solution needs to publish and consume batches of messages. So friends, if you want to understand why I didn't go ahead and choose storage queues here, then just keep scrolling on this page and look for the comparison between the storage queues and service bus queues, and you will understand why storage queues cannot be used here. So folks, go through this comparison table to understand in which use cases you should use storage queues and in which use cases you should use service bus queues. You have 100 Azure virtual machines with the system assigned managed identity enabled. You need to identify the value of the object ID attribute for each of the identities. Which command should you use? Your options are get Azure AD user, get AZ resource, get Azure AD user owned object, AZ AD signed in user list owned objects. Folks, you can use get AZ resource commandlet, which can list all resources including VMs. When the VM has a managed identity enabled, the VM resource contains an identity property with the object ID of that system assigned identity. And the right command is now on your screen. Let's look at question number 73 of the series. You develop applications that integrate with Microsoft Entra tenant. You plan to implement a permission classification in the tenant. You need to select permissions to include in your classification. Which permissions should you select? Your options are app-only access permissions that require admin consent, delegated permissions that require only user consent, app-only access permissions that require only user consent, delegated permissions that require admin consent. To implement a permission classification in a Microsoft Entra tenant, you should select delegated permissions that require only user consent. This is because permission classifications in Microsoft Entra ID currently support classifying delegated permissions that do not require admin consent. Next question. You have an Azure virtual machine named VM1 running Windows Server 2022 and an Azure Key Vault instance named KV1. You are developing a .NET application named App1 that you plan to deploy to VM1. You have the following requirements. App1 will require access to KV1. The identity used by App1 to access KV1 must be automatically deprovisioned when VM1 is deleted. You need to identify the procedure that will meet the requirements. Which three actions should you include in the procedure? Your options are create a user assigned managed identity for the VM, modify access policy on KV1, retrieve an access token from Azure instance metadata service endpoint, create a system assigned managed identity for the VM, retrieve an access token from the Microsoft Identity Platform endpoint. Now folks, you should start with creating a system assigned managed identity for the VM. This ties the identity lifecycle to the VM. When VM1 is deleted, the identity is automatically removed. Next section would be to modify access policy on KV1. This includes granting the VM's managed identity the required permissions. This allows the identity to be used for key vault access. And the last step would be to retrieve an access token from Azure Instance Metadata Service endpoint. Code inside the VM calls the local endpoint and gets an access token from the key vault. Next question. You are developing a Java application to be deployed in Azure. The application stores sensitive data in Azure Cosmos DB. You need to configure always encrypted to encrypt the sensitive data inside the application. What should you do first? Your options are create a new container to include an encryption policy with the JSON properties to be encrypted. Create a customer managed key and store the key in a new Azure Key Vault instance. Create a data encryption key by using the Azure Cosmos DB SDK and store the key in Azure Cosmos DB. Create an intro ID managed identity and assign the identity to a new Azure Key Vault instance. Friends, you should create a CMK and store it in the Key Vault. Client-side encryption in Cosmos DB uses a two-tier key system. Customer managed key, which is called as CMK, and data encryption key, which is called as DEK. CMK is the master key you control and store securely, typically in Azure Key Vault. Now, DEK is used to encrypt or decrypt the actual data fields, which is stored in Cosmos DB, but always encrypted with the CMK. So friends, I hope you now understand what is the concept of CMK and DEK and how they are used in Azure Cosmos DB. Folks, that's all for this part of the series. I'll see you soon in further parts of our Microsoft Certified Azure Developer Associate Ultimate course. If you have not watched the previous parts of the series yet, then link to the playlist is available in the description section of the video. Make sure to explore all the videos to gain the maximum benefit from our content.